Hello everyone, thank you for joining this demo. Let's start with a bit of history before we jump into generative AI topic. 10 to 15 years back, data warehouses are primarily for batch analytics. Over a period of time, they evolved to support real-time streaming analytics and machine learning workloads. Now the evolution took one more giant step, that is generative AI analytics. Generative AI technology already making huge impact in businesses, and it has potential to scale much higher with an anticipated revenue of 4.4 trillions annually. Let's see how a cloud data warehouse such as Amazon Redshift is adapting to this technology. Myself, Satish Sonti, Senior Specialist Solution Architect at AWS. In this session, I'll walk you through Redshift generative AI capabilities, particularly the integration with Amazon Bedrock. In this slide, you see various Redshift features ranging from ingestion options, data sharing capabilities, and consumption features. We'll not go in depth into each of these features, but the one which is of focus for this session is Redshift AI ML integration capabilities. We'll dive deep into this in this session with a demo. If we zoom into Redshift generative AI capabilities, there are largely three integration patterns that are currently supported. You can have LLMs in Amazon Bedrock, deployed in SageMaker Jumpstart, or in SageMaker, and use those LLMs with Redshift native integration with all these three services. These three integration patterns have varying degree of customization and ease of use. If you take Amazon Bedrock, which we're gonna demo in this session, the service is fully managed. You don't need to manage the infrastructure, and you can access those LLMs just by enabling the access to the users and start running the generative AI analytics. Let's see the demo of the first integration pattern in this session. We take a healthcare industry use case for this demo. As part of this demo, we will generate personalized diet plan for patients based on their conditions and the medications they are taking. It's a very straightforward integration. You have your data in Amazon Redshift and your model in Amazon Bedrock. As a first step, you will enable the LLM model access in Amazon Bedrock. Then the second step is to load sample patients data into Redshift. And you need to prepare the prompt to pass it on to the LLM deployed in Bedrock. So you do a little bit of prompt engineering. Then you'll create a model referencing the LLM sitting in Bedrock. Then your initial setup is done. After that, you will get a function which you keep using in your SQL statements to generate the personalized diet plan for the patients. Now we are in the first step, that is to enable the model access in Amazon Bedrock. You are seeing Amazon Bedrock management console. If you scroll on your left navigation pane, you'll see model access. And if you click on modify model access, you will see all the LLMs that are available for use in Amazon Bedrock. For this demo, I'm using Anthropic Claude, so I'll search for that. I already requested access, so the access was granted. But if you need to get request access, it's a very simple process. Select model of your choice. For example, in this, I'm selecting Claude 3.5 Sonnet. Then click on next and submit, and your administrator can grant access to that model. Here I already requested the model and got the access. So I'll move on to the second step in our demo, that is to load the data in Amazon Redshift. Now we are in Redshift Query Editor V2. Let's create a patients table and load sample patients data. Go ahead and run this command to create the table. Table is created and I'm loading some sample data into it. Okay. You can look at the sample data to get a feel of how the data is. Yeah, it has patient ID, patient name, and their condition and the medication they are taking. This we will pass it on to the LLM model to generate personalized diet plan. So prior to that, we should do a little bit of prompt engineering. So if you look at it, the patient names and the conditions are in different rows. We should bring them into a single row for passing as a prompt. So here I'm running aggregation functions to combine the conditions and patient medications per patient. and we will further group them down and create like a prompt in the next SQL. Yeah, if you look at this, you see a nice prompt created, like Jen has viral sinusitis, bronchitis, taking so and so medicine, and now this is ready to pass as a prompt to the LLM model. We can just pass this output also to LLM model, or for better readability we are creating a materialized view using the same SQL statement. I'll go ahead and create a materialized view. This is not necessary, but just for readability we are creating it. Let's look at the output of materialized view. Yeah, it has the patient ID and the prompt neatly formatted. Now this is the step where we will create the model. This model references the Anthropic Claude v2, and we have a prompt passing to the model. This is a static prompt. However, we have other options which I will discuss further down. And we will go ahead and run it, which will return a function called patient recommendation functions, and that function we will use to run the inferences. So let me go ahead and run this. So the model reference created, and we have a function created for us to use to generate inferences. So let me come down and run this SQL to generate inferences for 2 of the patients. So when we run this, the prompt is passed on to the LLM, and LLM generates the diet plan and send it back to Redshift. So you can copy the output and paste it in a notepad for us to look at the multi-line output. So this is the generated patient plan for Emma, who has hypertension and bronchitis and taking this medication. And we also have personalized diet plan created for another patient. Let's see what it has. So this patient has diabetes and sinusitis and taking these medications, and the generated diet plan is particularly personalized for Deb, who has these conditions. So that concludes the demo for a simple call to LLM and generate responses, all with SQL statements. You don't need to learn any other skills. Now we'll see further options that are available in this integration. Let's say you would like to make a simple call without passing any data from your data warehouse, like a catalog function. You can run that as a leader node only function. So if you observe this SQL, we are calling the function, passing a prompt, but there is no from clause. We are not passing any data from data warehouse. So you can make a simple question to LLM using an SQL call, and you will get the output. And this is not a personalized diet plan which I'm generating here, because I'm not passing any specific patient information. So all we get is a very generic response as a simple call to LLM. So I just want to demonstrate you can use this integration as a leader node only function too. Let me copy paste this output to a simple notepad. So if you look at this, it's a 7-day diet plan for somebody with pre-diabetes, and it's not specific to any patient. So you can use this integration for such a kind of use cases too. The next option is to set the additional parameters while making a call to LLM. If you look at here, along with the prompt, I'm also passing optional parameters like temperature. What temperature will do for this model is it will increase the specificity based on the value you set. It ranges from 0 to 1. For the first call, I'm generating the recommendations for patient ID 101, setting the temperature to 0.2. Let's see the output. And we will do the same call for the same patient, increasing the temperature. Then the specificity of the output changes according to the parameters we are passing. So if I copy paste this output into a notepad and look at the output, I'll just move it here for you to quickly have a look at it. This is how the output for the call that we passed on with a 0.2 temperature. I would like to focus on 2 recommendations here to show you the difference between 0.2 and 0.8. This is the output generated with 0.2. If you look at the recommendation, stay hydrated, drink plenty of fluids like water, herbal tea, and avoid dairy. and so on. And similarly, if you look at one more line, avoid soy, gluten, processed foods, this may disrupt thyroid function in some people. Now what we will do is we will generate output increasing the specificity temperature to get more specific recommendations. Let me go ahead and run this. Now we will get a different output with more specific recommendations. So if I look at the output with markings, yeah, this is the output for the inference call generated with 0.8 specificity. If you look at this, same recommendation, but now it is much more specific. It is calling 8 to 10 glasses of water, and in the second recommendation, it is saying monitor TSH levels. It's giving the specific details. And what we are trying to tell here is based on the option you are passing, the optional parameters you are passing, we can influence the model behavior. Now we will see how do we create a model with request type defined as raw. So what it means is we are not defining any fixed prompt. Everything we will construct at the time of inference. Let me go ahead and run this. Now for this demonstration, I'm using Amazon Titan Text Express V1 model. You can use any other model, but essentially I'm just trying to demonstrate how you can create it with request type defined as raw. If you look at the inference call, everything I'm constructing at the time of inference and passing the patient's data, the prompt, and all the parameters. We just want to demonstrate another way of making this call. Here is the output. If you copy the output into a notepad, you will see the output in JSON format. Now let's look at the final option for this demo. If we need to look at the run metrics, which are critical to determine the cost of running these inference functions, like the input tokens and output tokens, you can define your model with response type as super. I will go ahead and run this. And when you run the inference call for this particular model, you will get additional run metrics, and with that you will be able to assess the cost of using the Bedrock LLM model. Let me go ahead and run this to generate the inference. Here you got the output. Now we will copy this output and paste it in a notepad. Yeah, if you look at the output, you see how many tokens passed, how many tokens written, and the latency. These metrics are critical for us to determine the cost and also to look at the response times. We also published a blog to provide you step-by-step walkthrough of the solution, and this is the blog. It has a SQL notebook for you to download and replay this demo. Thank you for watching.